Hey everyone, I want to thank you for tuning in to one of EPARTRADE's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode.
Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by AERA, Performance Plus Global Logistics, Feria Racing Components, PIC, Fifth Third Bank Motorsport, Croyer, C-Tech Manufacturing. I am Francisque Savignan, the founder and CEO of EPARTRADE, the racing industry, every minute, every day. This is episode 563. It's also the last one of the 2025 season. We'll take a little break in November to get ready for Race Industry Week. So today we're going to be talking with PIC. With me this morning are Judy King, the co-founder of EPARTRADE, and wonderful host, Mr. Chuck Lynch. Judy?
Thank you, Francisque, and thank you everyone for joining today. I have to give a huge compliment here. The heart of the PIC marketing team really have put a stamp on all forms of motorsports, and that's something that I admire. It's something I wish I could do, so I just truly admire it. So I just wanted to give a shout out to them. Chuck?
Good morning, and thanks to everybody that's joining us live. Yeah, happy to be here today and to speak with Joe and maybe enlighten some folks and clear some things up about coolant / antifreeze.
On to you, gentlemen.
Good morning, Joe. How are you, sir?
Good morning, Chuck. I heard that this is the last one for 2025, so maybe they saved the best for last between me and you.
I think you're right. So, I understand you have a presentation to share, so I'll just kind of let you make the run with that when you're ready to start that.
Well, we can do that. I don't know if you on your end, those couple videos I had sent you, at any point you want to kind of peek at those also.
Yeah, I kind of held off on the videos. Sometimes just how they can kind of bog down. I did not get those to Francisque.
Oh, that's fine. That's fine.
Yeah.
The reason I don't use too many videos is because sometimes the information itself, it doesn't go across the way you want it to. Bear with me and let me just pull this up.
Yeah, and then I can ask some questions while we're sitting on a slide.
Sure, definitely.
So, I have this conversation again on our tech line often because depending on demographic or whatever, people curious whether they need antifreeze. So, there's the confusion in the name, I believe. So, could we start with something, what is antifreeze / coolant?
Well, let's talk about the three real components of antifreeze. And let me know if you can see my screen right now.
Yeah, it's in minimized. It's not in your, there you go. Got it.
Okay, excellent. Well, listen, here's the three components of antifreeze. And the first one is water. Well, water is your best heat transfer fluid. A lot of people think that, antifreeze or the glycol that's in antifreeze, that's how you transfer the heat. But your true heat transfer is water. So it needs to be quality water. So there are specifications that you see here at the bottom of the screen. And these are written by ASTM. Caterpillar publishes their water requirements. Again, Cummins publishes them. And what you see at the bottom is an exact mirror of each OEM. So just understand good quality water should be used, especially on our end when we blend antifreeze itself. So, there are some issues with water. Of course, it freezes at 32 degrees Fahrenheit. And it also boils at 212 degrees. So what do we do about the freeze protection? Simplicity. We add glycol to it. And we'll talk about the exact mixture as to where the perfect world is. Of course, to prevent boil over, we use a pressure radiator cap. And for different folks at different elevations, understanding that there's different pressures, whether at sea level or at 5,000 feet, 10,000 feet. And it's up to that OE manufacturer to make the recommendation that at this elevation, you should have a 10-pound pressure cap or a 12-pound pressure cap or a 15-pound pressure cap. We've done a lot of research in that area, especially in the mining industry, down in Colombia in South America. There were some issues with coolant failing, and the pressure cap was related directly to those failures. And then we talk about, well, you know, water is your best heat transfer. Glycol's there for two reasons. A lot of people don't believe this, especially when we get down into the warmer climates. They think, oh, I only need water. I'm not worried about freeze. Well, just first of all, glycol is there to prevent freeze. The second reason glycol is in the system is to prevent bacterial growth. So there are papers, SAE papers, that have been written as a team. Cummins and Caterpillar wrote this paper a number of years ago, and it refers to the issues with water system only in warm climates. And it's been proven fact that if you have a minimum of 33% glycol in that system, that you will prevent bacterial growth. I've done some of that research myself up at a company, a manufacturing company up in the Boston area. It was inside a building. They used their engines to produce heat for the building itself, and they used water only in their system, and bacterial growth was a great problem for this company. So let's just talk about the mixture of water and glycol. At a 50-50 mix, your perfect world is what we like to say, minus 34 degrees Fahrenheit, approximately the same thing, maybe minus 37 degrees Celsius. So that's your 50-50 mix. Understand that in the heavy-duty industry, all OEs prefer a mix somewhere between that 40% glycol and 50%, 60% water, or 60% glycol, 40% water. I actually sell glycol north of the border in Canada at a 60% glycol, 40% water mix because they want a greater freeze point. But that 50-50, that's kind of like a perfect world at minus 34 degrees Fahrenheit. The other component in coolant is your inhibitor package. So we're going to use quality water. We're going to use virgin glycol, so meaning it's not recycled. That's our recommendation. I don't know any OE that recommends a recycled coolant, and there's some issues with recycled. Folks can ask questions about it, and I'll answer those honestly. And the other component in coolant is the inhibitor package. So depending on if it's an automotive type of coolant, an older type of coolant, which we call conventional antifreeze, or modern technology today called extended life antifreeze, whether we're talking about automotive type of coolant or heavy duty type of coolant, that's the percentage and the type of inhibitors that we put into that gallon of antifreeze. So we could put 2% of inhibitors. That's kind of like a light duty automotive type of coolant, or upwards of 3 to 4% in a heavy duty type of glycol. And that's what prevents the rust and corrosion. And of course, in any wet sleeve liner application, any heavy duty engine application, we want to prevent pitting of liners. We want to prevent the cavitation of the block. Those inhibitors are designed specifically to prevent that from happening.
Okay, so quick question on the inhibitor package.
Sure.
So that would be your surfactants that change the surface tension of the water so that it doesn't make bubbles as easily, right, when churned.
That is correct.
So the oil pump churning in the
Yep.
diesel applications you mentioned, you know, so when I have the combustion event and it knocks the coolant away from the cylinder wall, then you create the little micro bubbles that implode and cavitate through the bores or through the liner itself. So if you can change the surface tension of water, then you can reduce its ability to make bubbles. Am I correct?
That is correct. Also, if there are, imploding bubbles against that liner, those inhibitors prevent that from happening. So there's conventional coolants that use certain inhibitors. And now today, the organic acid technology known as extended life coolant, it does exactly what you say. It prevents the surface tension between the bubble and the liner itself. So anyone listening to the call, that piston goes up and down, that liner ever so slightly, what we like to say, it vibrates. So the piston goes up and comes back down, the liner vibrates, it expands out and then snaps back to its original form. Ever so, minute in size, but that's where that steam bubble, that air bubble will burst against the liner and start to rip away a little flake of that steel. So that's one of the issues, big issue that occurred through the years. In a properly inhibited type of technology, you do not get liner protection. When using a quality coolant, like Old World's, like, some of the competitors, there are quality competitors out there for Old World, the Shell, the Chevron, the Prestone, the Valvoline, those are quality coolants that are in the marketplace. We all market quality glycol, we all use quality water, and we all use various types of inhibitors in the industry, and that's what prevents this from happening. Some of the new issues today in coolant systems, years ago we went through overdosing systems with inhibitors, underdosing systems with inhibitors. One of the big issues that came along back in late 2008, then into the heavy duty industry with 2010 production, and it kind of reared its ugly head in the off-road industry, is one of the components to in the system, what we call the radiator or your heat transfer, your heater cores, that composition where for years past we used copper steel, we used solder which contained either lead or tin in the solder itself. We've moved in heat transfer, and this is big time across the world, to fabricated aluminum. And there are older inhibitors that are not compatible with this fabrication of the aluminum. So we moved away from copper steel and the solder. We moved towards fabricated aluminum that what's used a process called CAB, controlled atmospheric brazing. That's how they put the tubes together in aluminum. And that process of controlled atmospheric brazing, it leaves a residue behind, what we call a flux. And when certain inhibitors mix with this flux from the fabricated aluminum, we're now back to clogged systems. We get fallout, we get radiator failure, those tubes start to fail. So that's another issue moving forward. So the technologies where we move from older technologies, back in the 60s and 70s into the early 80s, towards the extended life coolants in the late 1990s. The first one to use that was GM with Dexcool, and then the heavy duty industry looked at this, and in the early 2000s, we went with the red extended life coolant. A lot of these were inhibited with nitrites, and that's the inhibitor that counteracted with a lot of the flux. So the world itself, and I'm talking 100% of Asia, 100% of Europe, here in North America, every factory fill has moved away from nitrated inhibitors to nitrite-free inhibitors. And the only OE that I know in the world that still factory fills with a nitrated type of coolant is Caterpillar. They still, whether they use conventional coolant, which works extremely well, or extended life coolant, they are still inhibited with nitrite. So that's the inhibitor package right there that I'm talking about, Chuck.
Okay, so just a real quick question. Those things do not help with electrolysis though, right? That's a whole different setup. Or do they provide some protection?
Well, and that's where we get into the world that we're kind of moving towards, where we went from internal combustion engines. We started, in the real world to hybrid type of vehicles. And then we moved, in the past few years with battery electric vehicles. Some folks have asked about, what's the coolant for that world? Well, when you state that question about, electrolysis, metals, any metal that's in a coolant, and even some of the inhibitors are going to help send that electricity, as we'll call it, through the coolant. So the way these coolants are designed today, and where I use this organic acid technology, that's what's factory fill in any hybrid or battery electric vehicle today. They are very low, if any, solids that we like to call it in the inhibitor package. So it's still using ethylene glycol. It's still using deionized water, but the inhibitor package itself is free of any solids and of course, anything that's going to conduct electricity. So we like to say it's low in micro Siemens, and that's the direction that battery electric vehicles and the coolants that are factory filled in the automotive world, in any ICE engine, are the same exact coolants filled in their battery electric or hybrid vehicle. The same thing in the tests that are going on in the Class 8 world or Class 6 to 8 world. Those same coolants that are factory filled for whether it's Volvo Mack or for Freightliner or in the, any battery electric vehicle manufacturer, the coolant that they use in their ICE engine is the same exact one that they're using in their battery electric or hybrid type of vehicle.
So we've hit on some of the BEV, electric, hybrid, and talked a lot about heavy duty. So comparatively, what's the difference between the, transportation and energy demand world versus performance?
Well, I'm a little confused with your question there, Chuck. Are you comparing automotive coolants to heavy duty Class 8 coolants?
Right. So
Right.
Automotive versus that, and then, the racing or performance world. Yeah.
Right. Well, in the racing world, we all understand that ethylene glycol, or antifreeze, as we like to call it, they kind of frown against that in that industry. In drag racing, there's nothing, in that system, when you get into, John Force racing and that type of stuff. Some of the other vehicles do use wetter and just water to cool that engine running down the track. We don't want to see glycol on any type of racetrack. It's way too slippery, and if it gets into the asphalt, it's almost impossible to remove that from the asphalt. But in thinking about the automotive vehicle, your vintage car, you're looking at the same coolant goes into heavy duty as it does in the automotive. So they're water, they are ethylene glycol that we use, and there's an inhibitor package. And it's the inhibitor package that differentiates older vehicles to more modern vehicles to heavy duty Class 8 vehicles. Those type of inhibitors are what help prevent liners from pitting and blocks from cavitating, whether they're in some sort of light duty vehicle, medium duty vehicle, or heavy duty vehicle. So your inhibitors, and that's where you get into play, where you look at inhibitors that are approved in the heavy duty industry, approved for Asian vehicles, approved for European vehicles, and also certain inhibitors are frowned upon. They're actually banned in Asia, certain inhibitors. Certain inhibitors are banned in Europe. Like I talked about nitrites before. Nitrites are banned in Europe completely, environmental reasons. In Asia, they frown upon silicates being in their inhibitor package. So it's an interesting balance, whether it's automotive, whether it's heavy duty, and trying to say, well, is there one coolant that I can use across the board? And that's the direction we at Old World look at in saying what coolant is approved in Asia, Europe, and here in North America. What's one formula that can be used in probably upwards of 95, 98% of every vehicle produced? And that's the direction any blender for coolant kind of looks at. We do have different formulas. We probably private label 168 different SKUs out there. We private label a lot of coolants for a ton of people in the industry. We produce old technology, you know, the good old-fashioned green coolant that we used back in the 60s and 70s. A lot of farming equipment still uses green antifreeze. And then the color changes, and that's another subject we haven't even touched on yet. You know, the different colors coming out of Asia and Europe and here in North America. We can touch on different factory fills and tweaking of colors and stuff like that. So there are differences in the inhibitors, and in some instances, the coolant coming out of production, let's just say from Hyundai to Toyota to some other Asian, exact same inhibitors, exact same glycol and exact same water, just dyed different colors so that OE can identify their coolant in that part of the world. That's the only reason certain coolants are dyed that color coming out of Asia. Here in North America, you know, we've been on GM has been for the past 30 years. They've used orange Dexcool as their color of choice and their type of technology. A lot of growing pains back in the late 90s into the early 2000s till, you know, the components under the hood of that vehicle were extremely compatible, where there was some incompatibility in 96 and 97 of components, whether it was O-rings or seals or gaskets, there was some incompatibility. Today it's compatible, and GM has been on orange Dexcool. Ford has moved around from certain greens to the gold motorcraft coolant, certain type of technology. They moved to an orange coolant a few years ago, and today they're yellow factory fill. So there are differences in all four of those. And when I talked about Ford, Stellantis, or as people like to call it, Chrysler, today they're a purple factory fill, where a couple of years ago they were the gold type of motorcraft coolant was a factory fill, and they even had a yellow factory fill. So we're all different colors you see in the industry. You know, we can talk about heavy duty, the evolution that went from green to that fuchsia, that pink or purple type of coolant. We call it fuchsia in the industry. So we moved from green to fuchsia. That was the fully formulated coolant. And the first generation of heavy duty extended life coolant was the red coolant. But that first generation developed by Texaco way back in the late 90s was at what we call an NOAT. So it was similar to Dexcool, that orange coolant that GM used, but they enhanced the inhibitor package with nitrites. And to distinguish it from Dexcool, dyed orange, they decided to dye it red. So red became the color of choice in the heavy duty industry. And that is what you see factory fill in Class 8 vehicles here in North America today. Your Navistar, or International, I should call it today, as we dropped the name Navistar. International, we factory fill for them with a red coolant. Volvo Mac, we factory fill with them with a coolant that's kind of orangey red, but it's closer to red than it has been orange. And then, of course, factory fill at Freightliner. Detroit has been red for about 10 years now, maybe 12 years. And what's left is PACCAR or Peterbilt Kenworth. They had a little bit of pink, hot pink coolant for a couple of years, factory fill. Today it is red. So red kind of indicates extended life coolant for the heavy duty industry. We've got Toyota Asian red in Toyota. It used to be very dark red. Today it's more pink to distinguish it a little bit more for Toyota, Lexus, and the Asian vehicles. So hopefully these colors kind of unconfuse people, even though mixing of colors like out of Asia, there's no difference other than the dyes in that area. There are a lot of differences in other technologies. So if a major fleet is using a coolant, they stick to one coolant across the board. I'm going to advance my screen, and you can ask more questions as we move along there, Chuck.
All right. Yeah, sounds good. So as people are potentially mixing these, is it a good practice to do some kind of flush before you refill if you know that you're going to mix?
Well, here what you see on the screen here, the old conventional green coolant, that's been factory filled for a number of years back in the 60s and 70s and into the early 80s. Every vehicle produced had green coolant in there. So there was no way to buy coolant any other way than, you bought a case of coolant for your Class 8 vehicles. It was concentrated, so you use your 6 gallons of concentrate, and you fill those same 6 gallons with water, and you topped it off, and you had your 50-50 mix. And then you added some sort of Nowco or Nowcool, some sort of Penray or Pencool. Detroit had its Paracool. There are some other SCA inhibitors. You charged up that type of technology. So now, we've moved away from that technology as factory fill. And that's where you see at the bottom of the screen here, the organic inhibitors. In the screen, it shows as like a yellow or amber or even orange type of coolant. This is where we move to the organic inhibitors. So no silicates, no borates, no nitrites in this type of technology. The one change that you do see today coming out of Asia, and this was created to passivate the failure with fabricated aluminum. We started to see low doses of phosphates into these type of technologies. And it's a direction even old world is starting to look at. We have a formula now that's a low phosphate. We call it a POAT, where OAT has been in the industry, the terminology, for a while. NOAT, HOAT for a hybrid type of coolant. That was the motorcraft. Today, we're calling it a POAT, so a POAT. And that's where a low dose of phosphate is helping passivate any issues with fabricated aluminum. And even Caterpillar now markets for their industry a little dose, a little pint bottle of an additive, and all that's in there is a dose of phosphates. We even had this marketed by one of the OEs for a number of years, where they realized they needed to add a low dose of phosphate into their coolant system to help passivate with this fabricated aluminum. So that's where we are today. I know I'm throwing a lot of stuff out here on technology, but it's just the direction that the world is going at.
Right. Joe, I think this is probably a good time. We'll tell the audience, if you have a question, feel free to drop it in the chat box, and we'll answer these as we go rather than wait till the end. So
right.
Again, yeah, if you got a question, let's hear them.
Yeah, and I think you can see on the screen now this SAE technical bulletin, using glycol instead of treated water. So this is the technical bulletin that was written by Richard Herkamp from Cummins, along with Frank Kelly. Both of these have passed away since they wrote this paper, but it talks specifically about using glycol in all systems. So whether it's off-road, marine, locomotive, and you don't think you need glycol in your system, you do. So, especially in warm weather climates. That's what this paper was written about. There are 5 areas of testing coolant that we want to utilize, and any technician in their shop should be utilizing these 5 test procedures. And if a question comes in, Chuck, just slow me down. I'm Italian from New York, so I got a habit of talking with my hands and rattling on. So shop testing of coolant. So any technician, look, it could be red, pink, yellow, green, gold. I don't care what the color is, as long as it's a nice fluorescent color. It shouldn't be black or dark brown. We talk about clarity. Just take a little couple ounce sample out of a system. Always take a sample out of a low point in the system if you can. Remove that coolant filter. If you're making a change, take the coolant. Let the first few drops or first couple ounces come away, dispose of it, and then get the next 4 ounces out and take a peek at it. Make sure there's no oil, fuel, or corrosion in that sample. You want to be able to see right through it. Let it cool off to room temperature, somewhere between 50 and 100 degrees. You see on the screen here a refractometer. My goodness, just now up in New Hampshire, I was getting complaints about, hey, your coolant, it's not, the freeze point is way off. It's only down around, -5 degrees. And I'm like, well, what are you using to test it? Well, we're using a hydrometer. Well, that's the tool that you suck up coolant and has a little floating needle or floating balls or pellets in there. That tool is not accurate when testing coolant. I'm just telling you this. This guy was testing coolant right out of gallons off his shelf. A customer was complaining to the distributor. Well, we shipped him a refractometer. He used a refractometer immediately, and every gallon of coolant tested at -34, -35 degrees. So make sure you use the proper tool. That analog refractometer on the right, that is the correct way to use it. If anybody ever has a question about how to use it, just reach out to me. Again, you knowing on the automotive side, they allow down to 30% glycol to 70% water. In the heavy duty side, we prefer 40% glycol. So depending on your freeze point, depending on what part of the country you're in, a 40 to 60 mix is going to give you, -12 to -65 degrees. That's probably perfect across any part of this country. So
okay.
you also,
yeah, go ahead with the next point, and then I got a couple of questions.
Sure. So there's a pH, the test strips that we're going to market in the industry, they have a pH test strip on there. Anywhere from 7 to 11 is a pass, even a little below 7 today. And again, I'll show you the test strip as we move forward. The test strip is going to test your acid. So if you're using old technology, green technology, the nitrites, if you're still using that, again, there are some fleets, many transit systems still use that. The test strip will measure your nitrite levels. If you're using nitrite-free coolant, well, now we have to test the organic acid. They're going to read it simple, pass or fail. So let's next move on to the question, and then I'll talk about the test strip.
Okay, so the first question, because it's kind of going back a little bit. So
Sure.
From a member that Amian messaged and said, hi, if you have a cast iron block, is there any advantage to using water wetter for cooling purposes?
Okay. Well, listen, what I don't have for anybody on this call is an approval from the heavy duty industry to say use water wetter. Water wetter is used really in the racing industry. No issues with water wetter. So if you're going to use water wetter on top of glycol, there are no issues. You're not going to affect it. You're not going to hurt the inhibitor package. You're not going to change the pH all that much. You're going to kind of help the system, especially the water pump area and the coolant flow through the system. You're not going to hurt it at all. In your racing world, I think you have a demand to use something against that water itself that may have flash rust. So that water wetter may help in flash rust. I can't tell you that. I've never done that study. I've done it for Caterpillar, where Caterpillar may, drain out an engine, rebuild an engine, then shrink wrap that engine and put it in a corner till there's a demand for it. And we've seen a lot of flash rust in engines that used water to flush out what was in that system, and the water's left in there. So there are certain procedures people want to know when rebuilding engines to prevent flash rust, for refilling engines and stuff like that. So no issues with water wetter at all, especially on my heavy duty side. On the automotive side and your racing engine, you guys make that decision.
Okay. And then before we move on to the glycol slide here, question in regard to the testing frequency, because we've been conditioned as automobile owners that so many of these are maintenance-free vehicles now. So we extend everything. And I know we have extended drain intervals on oils and coolants and everything. But at what frequency should we test our coolant?
Well, I'm going to go first. Let's start with the Class 8 world. The heavy duty engines, the Cummins, your Detroits, they all put in writing that they're still looking for that technician. Hey, you're bringing the vehicle in, whether you're changing oil, even though you have an extended oil change interval, you're kicking tires. somewhere in that 90 to 120 days. So I want at least twice a year to do those 5 test procedures to check the coolant. On the automotive world, at least once a year. Hey, things can happen out on the road. The driver may, lose some coolant and top it off with just water. So he'll change that water glycol content. You may get a driver out on the road and grab a different type of gallon of antifreeze to top it off, whether it was factory fill or what that fleet is using. So the testing procedures will let you know, hey, something's wrong in here. So minimum twice a year, minimum. On the automotive world, at least once a year, you should be checking your coolant. These coolants in the automotive world, everyone factory fills with a coolant that's somewhere in the minimum of 5 years, 150,000 miles. So you're talking about every year you should check that coolant. Make sure the color's still vibrant. Make sure there's no debris in the system.
No, thanks for that.
You got any more questions, Chuck? I'll slow down.
Oh, I think we're good. Let's
okay.
move on.
Well, let's just as quick as possible. There's always the question, hey, can I use recycled coolant? Again, I don't know any OE that puts into writing that you should use or can use or approves recycled coolant. Some of the things you want to know, and let's keep this brief and simple. Virgin is always better. We know it's pure. On the recycling side, there are 5 different testing procedures that are out there in the market, actually 4. And if you look down to the 3rd bullet where it talks about it, filtration, well, that does nothing to recycle the coolant. All it does is pull out some of the solids in the system. Ion exchange, very difficult to run in recycling. Not a lot of people use it. Reverse osmosis, that's where you're pushing water through a membrane, very expensive to run. Distillation is where folks do a lot of recycling today. It's more cost effective. But remember this, to use recycled coolant and recycle it properly probably costs more money than virgin coolant per gallon. So if somebody comes along, and I'm just going to pick numbers without upsetting too many people on the call, you're buying a gallon of coolant and it's $11 a gallon, and somebody comes along and says, hey, I'm $3 a gallon, you have to be buyer beware. I mean, just be an educated consumer. If anyone is using recycled coolant, you always want to have that recycled coolant analyzed by a lab to let you know that they did a good job. Which you want to realize this, when you get a coolant that's not properly recycled, there are degradation acid levels that are in that gallon of coolant or that drum of coolant or that tote of coolant. And if there are any degradation acids in there, meaning that the glycol's aged a little bit, it's going to accelerate as soon as you put it into use in the system. So just buyer beware when you're doing a recycle. So I kind of touch base on this slide right here, battery electric coolants, in my discussion earlier. There are documents. I just finished writing a document for the Technology and Maintenance Council. That's TMC. So there is a published document right now. If anybody needs to review it, it keeps it simple because there's not a whole lot going on. ASTM started this a few years ago. And I can tell you about a year ago, they tore it up, threw it away. And now they're reviewing it again. So there's no official document at ASTM right now. This is my contact information you see here on the screen. If anybody tomorrow, next week, next month has coolant concerns, reach out to me. I do answer every single email, every single text message. Difficult to answer the phone every time it rings. Again, I'll leave this up on the screen for a couple seconds if anybody wants to take a snapshot of it. My expertise is on the coolant side, helping to write specs for fleets, helping to write specs for cities, towns, municipalities, letting you know if a coolant meets that spec of Caterpillar or Cummins, especially Cummins. Cummins is so strict when it comes to what's allowed in their engine. And remember this, that Cummins engine could be in a Peterbilt, a Kenworth, it could be in a Freightliner, it could be powered into anything. So Cummins doesn't, Cummins write their specs, but Cummins doesn't demand what that OE puts into their coolant.
So going back to the earlier part of the conversation, so we've talked about, antifreeze, but I think sometimes it's missed that the pressure in the system and the addition of a coolant actually allows you to run higher temperatures. The system works like a pressure cooker. So
Correct.
what impact does the coolant have on that? So I know if I have pressure on the system, there's a mathematical linear scale of say, okay, if I have 2 psi of pressure, then the water is going to boil at 220 as opposed to 212. So
Right.
what are the impacts of coolant on that too? So it also protects you from overheats as it does freezing. Can we kind of elaborate on that a bit?
Well, the freeze, there is a glycol chart that'll tell me or any end user, and I probably have one right here behind me. It's just a simple glycol chart that'll tell me that at 50% I'm minus 34 degrees, and at 30% at a certain freeze point, at 10% glycol I'm at a certain freeze point. On the boil over side, just know this, that the higher any system operates, so we start to get above 200 degrees and 210, the glycol, that's what degrades the glycol, is the higher the temperature. That'll start to degrade it over time. So it's important not to overheat. It's important to maintain your system so it doesn't run super hot. So, I want to repeat something here, and I know, we still got 15 minutes to go, I think, where more questions are going to come in. The testing of coolant for any technician, color, clarity, pH, and the test strip, and I'm just going to put this up to the screen here. There's a pH pad on test strips. This works in every single coolant. So the coolant itself, so whether it's dyed red or blue or green or pink, you test your pH and just make sure she's 7 to 11. You'll know pH is bad above 11 because it's going to stink like ammonia. Ammonia will tear apart head gaskets and O-rings and seals and hoses and on and on. So if you've got a foul odor like ammonia, you need to drain, clean, and flush that system. You can't lower the pH in a cooling system. So when a pH is here, we expect it to lower itself over time. But when a pH is already elevated and it's in an ammonia state, you must drain, clean, flush, and refill. So this is a test strip that Old World has in the marketplace. It's an all-in-one test strip. This will test, and you can probably see here clear as day. I hope it's pretty clear, where this says pass or fail. So there are different technologies in the industry. So we can say older technologies for organic acid, newer technologies for organic acid. There's nitrided organic acid. There's nitrided coolants. This will test every single coolant in the industry. Pass or fail. Simple as that. Don't use test strips. Do not use test strips to test water glycol content. Use the refractometer. That is the most accurate way. Test strips, you could be off by 30, 40, 50 degrees. Don't use test strips. I dwell that into everybody when I do trainings like this. When I do NHRA trainings, I travel the country for John Force Racing, and I bring my customers in to a hotel, and we'll do trainings. We'll spend 2-3 hours talking about coolants and different coolants, and we talk about DEF. And one day, hopefully, I'm invited to EPARTRADE next year to talk about diesel exhaust fluid. That's a big question that a lot of people have. Our Blue Def brand and versus other brands in the industry. What's the difference from A to B? Is there a difference from A to B when it comes to diesel exhaust fluid?
Interesting. So back to the test strips, often if you have a condition where you're getting hydrocarbons in the coolant,
Sure.
that's typically used to identify maybe a head gasket failure or something of that nature.
So I'm going to preach for a different customer, right? So you asked that exact terminology, hydrocarbons. So there is a company out here called AccuStrip. They actually produce this test strip to test to see if there are hydrocarbons in coolant, in diesel exhaust fluid, or in your pool. This will test any aqueous liquid to see if carbon, whether it's oil or fuel, anything got into your system that's water aqueous. Big issue in rivers and streams in the boating industry, where you got folks just dumping oil into the pond, lake, stream, or into the Hudson River in New York. They utilize this type of test strip to make sure there's no hydrocarbon in the water.
Okay, it's great to get that kind of confirmation, because there's a lot of stuff that gets sold out there that doesn't really cut the mustard when it talks that it's used to test for this or that.
Right,
so,
right. So again,
great product.
You had my contact information there. I don't market these. I don't sell these. I just teach that there is a carbon test strip in the marketplace.
Yeah, it's all about helping the industry, right?
That's it. Just help the industry.
So, again, something I would kind of elaborate, going back to pressure on the systems. We were talking about the radiator caps being different for different areas, different altitudes. So is that more something that you would expect to see based on the, class A or more stationary equipment? Say if it's mining, excavation, things of that nature.
Right. It is the mining industry, the copper mines out in Arizona, down in Colombia, it was an issue, very high altitudes in the mining industry. There's a lot of mining that goes down in Chile and down in Peru. We kind of do a lot of business in that area. We private label Mobil's coolants, and they bring me into a lot of situations where this actually has occurred, where the wrong pressure cap, why did we lose this system? And the wrong pressure cap is on that system, because water, we all know, reacts differently at sea level versus 10,000 feet, totally different. So it's important for the OE to tell what pressure radiator cap belongs on that system. It's not up to me to tell them, it's the OE to tell them.
Yeah, interesting. Yeah, that's something that never usually gets covered, because I often share that the pressure system, say the pressure in the block is different than the pressure in the head. And then once it's different again, once it's beyond the thermostat. So, again, the whole pressure cooker methodology, they use that to their advantage. So the pressure's higher in the block to resist the bubbles being formed and things of that nature as well. So yeah, it's about a system, but you have to go with the OE recommendations, because every cause and effect, right? Anything you change is going to impact something else.
So if the bubbles get into the system, now your inhibitors have to be up to speed to prevent liners from cavitating and the block from pitting. Well, you guys are back.
Yes. We're little timekeepers here. So I just wanted to step in and say, if anybody's going to be in Vegas next week, Peak is exhibiting at the Apex show. So be sure to stop by. They're in booth number A1838.
Well, I get to leave for Vegas in the next 24 hours for John Force Racing. So I'll be there tomorrow and Friday and Saturday for John Force Racing. Peak will be there also in the hospitality tent for John Force.
Great. Okay, Francis.
Thank you very much. Great session, Joe, and thank you again. It's kind of a tradition. You close the the season. I believe like the third time in a row, and so we had a great season starting back in March. We run every Wednesdays, so this is our weekly webinar series. We call it Race Industry Now, every Wednesday from beginning of March to the end of October, and then in November that's when we get ready for our Race Industry Week. week. So we will be back live in about a month, December 1st to December 4th, for our 6th annual Race Industry Week. So please, go to EPARTRADE.com for more information and update. Register, sign up. We have a great lineup of speakers again this year. And then the weekly series will resume early March 2026. So,
and we're very thankful for all our sponsors, which includes Peak.
Absolutely. A big thank you. And thank you, Chuck. Was one of our new hosts this year. He did a great job. And again, thank you, Joe. Thank you, everyone. And we'll see you guys soon.
Thank you.
Let's go racing.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from EPARTRADE. In racing, every second counts. This is EPARTRADE, the premier business-to-business platform for the performance and racing industry. We connect buyers and suppliers 24/7 worldwide. Racing never stops, neither do we. Discover cutting-edge products and services from around the globe, gaining insights from our live platform, daily newsletters, weekly webinar series, and our highly anticipated annual Race Industry Week. EPARTRADE.com, the racing industry, every minute, every day.
ARP, the ultimate fasteners for whatever you build. To get the best performance, always follow ARP's installation instructions included with the product. For the latest torque specs, go to ARPinstructions.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components, circle track, drag racing, and any top race shop? In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crower Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crower Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crower Cams provides the muscle you need to dominate. And with Crower, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.